Hello, good evening. This is the second video on circular motion. We are on to the exercise 15B. I'm on to the first question. Now, if you remember in our first video, on the first part, in the first part of the circular motion, we studied about the horizontal circle. So it's the same thing, but this time this would be like a 3D case. Okay, we shall be having conical pendulums this time case. Okay, so I have tied here something with this to show you that what kind of this pendulum is. Okay, so if you look at this, I have this is a string tied from this point, and this object, this is moving in horizontal circles. Okay, so I have exactly the same kind of a situation in the first question of this exercise 15B. It says a particle of mass 0.9 kg is attached to a light and extensible string. If you can see this question here, okay, you can yeah, now you can see this question. Okay, so yeah, this is the first question. So I'll be doing this now. A particle of mass 0.9 kg is attached to a light in extensible string of length 2.4 meter. The other end of the string is attached to a fixed point on the ceiling. So this is going to be a case like this. Like suppose this is the point on the ceiling. Okay, and this is the string. You can see this. Should I change the color, the marker? Okay, let me change that. Okay, now this is the yeah, it's a string. This string is 2.4 meter long. Okay, and then it says there is an object over here whose mass is 0.9 kg. So that means the weight that has to be shown downwards. Oh, what is happening to my markers? Okay, now this is going to be 9 newtons. Okay, you can see this now. Okay, now as I showed you in this demonstration of this conical pendulum, this would be like moving like this. This this would be, this is the horizontal circle over here. Okay, so here is that vertical line. We are given that there is an angle of 25 degrees with the vertical over here. This is, oh, my marker is gone. Now this angle is 25 degrees. Okay, now then he says the particle is describing horizontal circles with the string taut and making an angle of 25 with the downward vertical. Find the speed of the particle. So we have to find the speed of the particle with with this given information. Now guys, the thing is the first thing required is that you must be very good at resolving different forces. Okay, and then again a good skill on algebra is required to solve such questions. Okay, now first of all, that this is moving in horizontal circles because this particle is attached with the string. So there is obviously a tension T over here in this string. Okay, we need to resolve this tension now. So this is going to be, this is your T sine 25 and this is your T cos 25. Okay, and later on we shall be needing to know the radius of this horizontal circle. So you can use this length, this 2.4 and this angle to determine the radius over here, which is going to be 2.4 sine 25. Okay, okay, so we have to find the speed of this particle which is moving on in horizontal circles. Okay, so now the first thing is, if you look at this, now this T cos 25 is going to be equal to this 9. These are the only two vertical forces over here, okay? So I'll be writing T, this is for the vertical components, okay? Now this T cos 25, that is equal to 9, okay? This upward component of this tension, that is equal to the weight, okay? Now since this is like, you know, there is this horizontal circular motion going on here, so I'm going to apply this F equal to ma thing now. Okay, so this is the force T sine 25, the net force applying onto it. So this is for this is T sine 25, that is equal to ma. The mass is 0.9, and since we're to find the speed, so I'll be using the acceleration as, the acceleration is v square over r. So this is m v square over r. As I told you that we shall be needing the radius, so the radius is this 2.4 sine 25, okay? So this is 2.4 sine 25, okay? Now this equation gives us the t, that is 9 over cos 25. I'll be using this value of t from here into this equation, okay? So this is going to give me 9 over cos 25 times sine 25, that is 0.9 v square over 2.4 sine 25. Now by solving this equation, you can definitely get the value of v.